Good day. My name is Dave Glover. Today I'd like to talk to you about DNS exfiltration and how NetWitness can be used to both detect and investigate these types of events. Let's start off with what is DNS exfiltration? DNS exfiltration is a process by which an infected host transmits a piece of data, which could be a sensitive file or files over DNS queries. The way this is performed is via a piece of malware located on the victim machine. The malware will take the file of interest, encrypt, and encode the file, sometimes using a base36 encoding method. The encoded text is then broken into small chunks and sent via DNS queries. These queries will recurse all the way to the attacker DNS server. Once all the queries have reached the attacker's DNS server, the file chunks can be reassembled and unencrypted, giving the attacker full access to the files and typically never tripping a security measure. The problem statement that we have is this is a very insidious path for criminals to transfer data out of an organization. They leverage the DNS protocol as a file transfer protocol. The challenge is that most of this data or most of these DNS queries are seen as legitimate. Most businesses don't even know that the data is being exfiltrated until it's too late. So how is this data represented within NetWitness? If we take a look here at a sample screen, we can see that in this example, the data is encoded using base36 encoding method, which NetWitness will actually look for. So if we take a look at the screenshot down below, we can see that each of these DNS queries start with a sequence number. This is how the attacker on the other side knows the order to reassemble these DNS queries. We can also notice here that the attack tactic will pick this up as an exfiltration event. So there are indicators within NetWitness to let you know that something just doesn't seem right. Let's go ahead now and take a look at a quick demo where I'll show you how this is actually incorporated within NetWitness. Once we log into NetWitness, we're presented with our typical dashboard screens. What we're going to do is we're going to go here and move over to Respond and take a look at what we've got for incidents. There's two incidents here that are of interest, Incident 50 and Incident 51. Incident 50 is possible DNS exfiltration for 192.168.31.180. Let's go ahead and take a look at that. Immediate glance, we can see that our source address of 31.180, which is how the incident was grouped together, it saw a very large number of DNS requests where they were TXT type records, which is not too common. But in addition to that, they were large DNS requests from a host name. So if we actually go ahead and highlight over one of these, we can see that there is a very large, what looks like random text before the domain name. If you remember back when we were looking at the PowerPoint, there are sequence numbers that start each one of these. So in this example, we have 357, which would lead me to believe that there are 356 before this, and there are possibly a large number after this, whatever it takes to transfer the files. So in just looking at this, we've got a very large number of events. What I'm going to do is I'm actually going to hover over here, and I'm going to investigate more around this IP address. So let me go ahead here and click Navigate. And the navigation screen comes up. We've got our filters up at the top. A couple of things here. Now this is a meta group that I use that has the meta that's interest to me and the types of investigations that I normally do. We can see here that we've got our base36 TXT record. We also notice this is coming off of a Red Hat box. Let's just scroll down and let's take a look at just what we see. At first glance here in the action event, company financials Excel file. It's a little interesting. But let's just go down here. Here are all those DNS requests, and here we have all the sequence numbers. So we've got 29 here, 108, 307. Again, this is how the attacker knows how to put that file back together in the proper order so that they can actually go ahead and decode that file and decrypt it. Let's actually take a look here at what's going on the Linux side. Now, we already have seen that this Linux box is making a large number of DNS requests. So let's actually take a look at what the actual log message that we've got going on around that. So I'll go ahead and right-click this, and I'll open this in a new tab. And what that'll do is that'll pull back all the data that's relevant for this time frame from this machine, and we can see all the filters up here on the top. And we see here that this is a Linux Mint box, okay, and it's doing a couple things, normal things. But this is where things start to get a little bit interesting. They're making a directory called NAS in mount. And now what they're going to do is they're going to mount the CIF share. Looks like they made a mistake there. So let's go ahead and scroll over just a little bit. Here we can see that they're mounting from the corporate file server from a financials directory. And we can see the user that they're using. And now if we take a look at the next one here, and as you can see when I hover over it, it pops up so it brings it to focus exactly what's going on. They're mounting that directory here to the NAS directory. Now what they're doing, if we go down to the third from the bottom here, they're actually copying the file to Home Dave Desktop. So Dave, he's a shifty guy here. He's doing all sorts of things. Now the next thing, let me actually scroll over just a little bit more. When you configure syslogging from Linux boxes, any privileged commands that are run on the system are sent out in syslog as they're run. The reason why this is so important, if we were to investigate this box later, they may have cleared the bash history, so I would not have seen a step-by-step as we're seeing right here. So this is really good that this is coming in via syslog, and I'm able to actually see these commands as they're being run. So now the next thing we have here is Python DNS send, Python script, server 1201. Now, that was the IP address that was the target for all of these DNS requests. And now we can see, as we can see the file here, that this is company financials Excel file, and this is my decryption password. So the identifier and the secret is what is being used on the other side after the file gets put back together. They're using that identifier to actually decrypt the file. And then we move on to the next one. We've got our super shifty Dave character here, and they're actually removing the file so it's not on the file system anymore. So to recap, this started with NetWitness picking up a large number of TXT records that had base 36 encoding for the hostname string. Now, once it saw a large number of those, it actually put those together into an incident and brought that to the attentions of the analysts. Once we were here, very, very easy. I'm able to just go ahead and pivot right over to navigate, which brought us to this screen. And then once we were there, we were actually able to drill into exactly what was done on that Linux machine. We see that they went ahead and were doing commands to send data over DNS. So that's the first incident that I want to take a look at. Now, we had the other incident of interest, which is this possible malicious activities for 192.168.30.129. So let's go ahead and click into that. Very, very similar here. If we take a look and expand this out, there's all these domain names again. Well, that's kind of interesting. So let's actually investigate this first event. In addition to collecting the Windows logs from this host, also have the NetWitness endpoint agent installed. Now, the endpoint agent is, in addition to collecting the Windows logs, it's also a full EDR solution. It's analyzing everything that's running on the host. It's taking a look at what's in memory. It's also taking a look at commands that are run. Now, one of the favorite commands of a lot of attackers is PowerShell, right? They can run obfuscated commands in PowerShell, and then no one's the wiser. So if we take a look here, we can see that, again, we have this Dave character. What they did was they went ahead and they ran PowerShell, and what we have below here is the actual commands that were run. Now, before we focus here for a second, let's take a look at these other 50 events. These are the same types of things that we saw on the other DNS exfiltration incident that we were just looking at. And again, we can see the same type of things. We have our sequence number, and then we have an encoding. Well, let's go back up to the first indicator here and focus a little bit more and see what's going on. Within the UI, I can actually do base 64 decoding. Why don't we decode this? Because I do know that PowerShell can take a base 64 encoded command and execute it. As a matter of fact, if I do that, no one's the wiser. It's very, very difficult to see what actually is being executed if you don't have these types of tools built right within your platform. So again, NetWitness does do decoding of base 64. So let's go ahead and decode this selected text. So here's our selection, and now let's take a look at what the actual decoded is. PowerShell execution bypass, okay, standard stuff. And here's what's extremely interesting. They're running a DNS Xfil.exe command. The host on there is 1202. Same one as we saw from the previous example, and also in these network events down below. So let's see what they're doing. So the file argument that they're giving is C users root /.workspace/.garbage./finance.db. Looks like they're actually taking a database that has a bunch of financial information. Now, we would be able to grab those packets and reconstruct those files within NetWitness as well. It's a little bit outside of this use case, but we can see here that here's that secret. So this is the password to decrypt this file once it's been sent, or more to the point, once it's been received on the attacker side. Without the endpoint agent on the Windows host, it would have been very difficult to get this information. My first step would have been to see all these network segments where these DNS requests are happening, and then go investigate the host machine. So I would probably have to go over there, taking a look at the Windows logs, hoping that PowerShell was logged, and then from there, I would have had to do my decoding, providing that it was there, and so forth, so on. However, within NetWitness, with having the endpoint agent on the Windows host, I get to see these commands as they're being issued. So in this sequence, we see that the first thing that happened, they ran this PowerShell command. It was encoded to sort of obfuscate so that users wouldn't see it. They ran it, and then what do we see next? All of the DNS exfiltration events. I hope that was useful for a quick example and demonstration for how NetWitness can help you identify and investigate DNS exfiltration events. Thank you very much.